Hey guys, and welcome to 3.2. It is called the graph of a function, and what we're going to do is we're going to look at a graph and determine, based on the graph, not the equation, whether or not it represents a function. Then once we have an equation, we're just going to be able to determine some features and answer some questions about the graph of that function. Okay, so a vertical line test is a way to determine whether or not the graph you are looking at is the graph of a function. Oh, sorry, I forgot to turn the light on. A graph in the xy plane, which is just the coordinate plane, is the graph of a function if and only if every vertical line intersects the graph at most one point, or sorry, they say in at most one point. It intersects once, not twice, okay? So what you want to do is just take any straight edge you have, move the straight edge like this, and if that straight edge crosses the graph more than once, anywhere on the graph, that would be not the graph of a function. Okay? So let's talk about, let's remember what a function is, right? A function is green, blue, red, paired with 1, 2, 3, right? On a mapping. So if green is 1, blue is 3, red is 2, that is a function because every G has only one, or sorry, every color has only one number. Every time you put in G, you're going to get 1. Every time you put in B, you're going to get 3. Every time you put in R, you're going to get 2, right? Or if you have coordinate points, if that's a set, is this a function? You're going to look, every time I put in 0, I get -4. There's no other 0 that's going to give me a different answer. Every time I put in 1, I get -1. Oh, no. Here, I put in 1, I get -1. Here, I put in 1, I get 6. This is not a function. Because for this x value, I have either the y -1 or the y 6. So on a mapping, it would look like this. 1, and here's -1, and here's 6. Oops, positive 6. 1 is going to map to -1, and 1 is going to map to 6. That is a problem, okay? Here, we can look at x. Maybe x is, that's -5. So maybe this is x -3, and that's y 2, but at the same time we have x -3, y -2. So that's why that is not a function, is because those 2 points that vertical line touched were 2 different y values for the same x value. So that -3 should only map to one number, but in this case it maps to 2 numbers. So that's why a vertical line test works. Every time I draw a vertical line on the graph, it will intersect the graph at one point, or it's also fine if it does not intersect the graph at all. Okay, so that would be not intersecting the graph at all. That's fine. Not intersecting the graph at all. Intersects at one point. So that would be a function. No matter where I drew my vertical line, it only touched the graph at one point. Okay? Then, here it touches nowhere, which is fine. That means it's still a function. But as soon as I find a place where it touches in 2 spots, it is not a function. Here it touches in 1 spot. Here it touches in no spots, but as soon as you have one place where it touches in 2 spots or more than 1 spot, it is not a function. Good. We'll test this guy. That's 1 spot, that's 1 spot, that's 1 spot. It never doubles back on itself, okay? So that one's a function. And we already decided that the fourth example is not a function because those two, that's an x of -3 and y of 2. And at the same time, we have an x, or in the same graph, we have an x of -3 and a graph of, or a y of -2. So that is not a function. So that would be the mapping of -3. Well, it would be the pair of -3, 2 and -3, -2, or -3 maps to both 2 and -2. Okay, you don't want an x with two different y's. That's what the vertical line tells you, whether or not you have an x with two different y's. There are not many questions on 3.2 for my math lab. They're just questions with many steps like this one, like G, A through G. So we don't need to know what the equation is of this graph. This is just a function. This is the graph of a function. We don't know the function necessarily, but based only on the graph, we want to answer the questions A through G, okay? Don't worry about these symbols. That just means pi over 4, 5 pi over 4, pi over 2, pi, 2 pi, okay? That's how we refer to them. So f is the function whose graph is shown. Pi over 4 is just a number, but it's the easiest way to express that number because pi over 4 would actually be a lot of decimals if you tried to write it any other way, okay? So let's look at A. What are f0, f pi over 4, and f7 pi over 4, right? Or f of. Remember, this is f, or f of x. What is f of 0? That means we put 0 in for x, right? F of 0 means that when x is 0, what is y? Remember, f of x is y. So when x is 0, what is y? We just need to find y when x is 0. Or when f of 0, what is y? Okay? So just look at your graph. When x is 0 on this graph, it's this point. When x is 0, y is 0. So we just say f of 0 is 0. So that's our first one. Then we have what is f of pi over 4. So now you just want to find the x value pi over 4. X is 0, x is pi over 4. When x is pi over 4, y is 2. What is f of 7 pi over 4? Just keep going. So f of 7 pi over 4 means that when x is equal to 7 pi over 4, what is our y value? So let's just keep going. We have 0, pi over 4, pi over 2, 3 pi over 4, 5 pi over 4, 3 pi over 2, 7 pi over 4, y is -2. Good? So that's all you're doing when they ask, what is f of 0? You just find x equals 0 and tell me what y is. F of 0 equals 0. Okay, so just to clarify a bit more about a function, right? If you had the equation, for example, y equals 3x minus 2, and we decided it was a function, we could change it to f of x equals 3x minus 2, right? But how do you know whether or not it's a function? You know if it's a function because it only outputs you one specific value for each input. Each x has only one y. If each x has only one y answer, if I put in 1, I will always get the same y. If I put in 2, I will always get the same y. If every x gives you only one y, it is a function. When it's a function, you can replace y with f of x, okay? F of x now equals 3x minus 2. So just like for this one, our coordinate points are x, y. Here, our coordinate points become x, f of x, okay? We're not changing anything except the name of y because it's a function. If y is a function of x, you can call y f of x. That's what we're doing here. That's why that looks like that, f of 0, okay? So y equals 3x minus 2 becomes f of x equals 3x minus 2. So if I said x equals 2, then that would look like y equals 3 times 2 minus 2, right? 3 times 2 is 6, minus 2 is 4. So y equals 4. But so that's all in terms of y, right? Let's do the exact same thing in terms of f of x. So f of x equals 3x minus 2. F of, when x is 2, we call that f of 2. So instead of x, I put a 2. Instead of saying x equals 2, I just say, instead of f of x, I say f of 2 equals 3 times 2 minus 2, right? So f of 2 is 4. Same exact answer, just a different way to write it, okay? So that is how we are finding the input is the number in parentheses next to the letter of the function, and then the answer, the output, is after the equal sign, okay? So our y is after the equal sign, our x is next to our letter. Good? And then, now we only have a graph. We don't have an equation to plug the x into. We just find it on the graph because they've already labeled some of the points on this graph. Okay? All right, let's look at B. B asks, what is the domain of f? Right? What does domain mean? Domain means all x inputs. So because this is a line, it's going to be in these terms, okay? Or we could say from here to here. It's not going to be a list of inputs, it's going to be a continuum of inputs, okay? All the x inputs. So on my x-axis, I can just decide where my x-axis, where my graph starts on my x-axis. Right? And where it ends on my x-axis. So the domain is from 0, right? We're starting at 0 for my x. And then what x value is this? This looks like 2 pi. I use the brackets because I can see that that's a point. If that point was hollow, if that point looked like this and it was an open circle, it would be a parentheses because that would not include it. But because that circle is darkened in, it means it does include the 2 pi. So that's why I wrote brackets immediately. I should have explained that earlier. So we start and include 0 and we go, the domain goes all the way through 2 pi. Okay, that's every x input possible, but on the graph, it's just where does it exist on x? It doesn't exist to the left of or negative of 0, and it doesn't exist positive of 2 pi. Good? Now the range, it's a very similar question, right? The range, just like domain is all your x inputs, your range is all your outputs. All y values, all outputs. It doesn't really matter when you're looking at a graph which one's the input and the output. What matters is it's the y's, okay? So the y's are the range. How high up on the y-axis does it go? How low on the y-axis does it go? So my graph will not go below -2. Remember, we're looking at y values for the range. So my y value is not 3 pi over 4. That's my x value. My y value is -2. And up here, my y value is +2. So my range, all possible y values, is just from, start with the smaller number, -2 inclusive to +2 inclusive. Okay? So that's the answer to C. Oh, sorry, and I should be putting that that's the range. And then that is the domain. Okay, D asks us to list intercepts. We have had some practice with intercepts. When they just say the intercepts, they mean both x, and y. Okay, you can just mark them on your graph. What are my intercepts? It intercepts y at only 0, 0. It intercepts the x-axis at 1, 2, 3, 4 other places. So it intercepts x at pi over 2, 0. Again at pi 0. Again at 3 pi over 2. And then again at 2 pi 0. Okay, those are your intercepts because that is where it crosses either the y, it only crosses the y at 0, 0, or the x. It crosses the x at 0, 0, pi over 2, 0, pi 0, 3 pi over 2, 0, and 2 pi over 0. Okay, those are the intercepts. Let's go on to E. How many times does the line y equals -1 intersect the graph? So this is definitely a new question, right? Where is y equals -1, okay? And if you don't know, it's fine to head over to Desmos. Oh. And just have Desmos graph it for you. Y equals -1 looks like that line. So if we transfer that line over to our graph, it just means we draw a horizontal line at y equals -1. Everywhere y equals -1, we're going to draw a line. How many times does the line y equals -1 intersect the graph? So an intersect is the same as an intercept, right? It's intercepting or it's intersecting the graph. It intersected at 1, 2, 3, 4, 5 points at y equals 0. The x-axis is y equals 0. How many times does a line y equals -1 intersect the graph, right? So they told me it's a line. They mean the line y equals -1. If there is no x value in my equation, I know it's either going to be vertical or horizontal, right? It only contains one variable. If the linear equation has both an x and a y in the equation, that means the graph is going to cross both the x-axis and the y-axis, right? If it only has the variable y, it's only going to cross the y-axis. If it only has the variable x, it's only going to cross the x-axis. So y equals -1 means it's going to cross the y-axis only at y equals -1, and it's going to be a straight line. So I'm just going to draw that line on my graph. I think that's the easiest way to solve this problem. So I'm going to draw that line, y equals -1. I found it because I know it's only going to cross the y-axis, never going to cross the x-axis, and it crosses the y-axis at -1. So it has to be a horizontal line at y equals -1. Or I just went to Desmos and graphed it. Also perfectly reasonable, okay? Now it's just how many times? How many times will this intersect the graph? It's not intersecting the graph here. Here the graph is up here. It's intersecting the graph here 1 time, 2 times, 3 times, 4 times. 4 times. So for E, the line y equals -1 intersects the function or the graph 4 times. 1, 2, 3, 4. F asks us, for what values of x does f of x equal -2? Okay, let's go back and look at A. A said, what are f of 0, f of pi over 4, and f of 7 pi over 4, right? When you replace x with a number, like over here, f of x equals 3x minus 2. When we replace x with a number, that is considered an input. So we put the number next to the f. So f of 0, 0 is the input. F of pi over 4 is the input. F of 7 pi over 4 is the input, right? And then we find the output. So the input of 0, output of 0. Input of pi over 4, output of 2. Input of 7 pi over 4, output of negative 2, right? In this case, f of x equals negative 2. I don't know my x. Here, I didn't know my y, right? Here, I don't know my x, but I do know my y. So that point is going to be, I don't know, negative 2. Or you can call it y, or sorry, x. Yikes, that's bad teaching. X negative 2, right? We don't know our x, we do know our y. So for what values of x does f of x equal negative 2? And it's okay if it's more than one number. You can have more than one x equal the same y. You can't have more than one y equal the same x. And I know it takes time to get used to that, but just find all the x values where y equals negative 2. What are the x values possible for y equals 2? Okay, so just like here we found the bottom of the range, here we found y equals negative 1. This is going to be y equals 0. The bottom of the range was y equals negative 2, right? Just like that number. Here's y equals 0. Here's y equals positive 2. And they want to know, oh, they want to know y equals 2. I don't know why I thought y equals 1. So it's already done. We drew a line there, and we can see our 2 points. When y equals negative 2, x can be either pi over 4 or x can be 5 pi over 4. This isn't how I would write it. I would write it as the 2 points, the way they wrote it. So it's either pi over 4, 2, or 5 pi over 4, 2. Those both have an x or y value of 2. So the x values possible for y equals 2 are pi over 4, or 5 pi over 4. And then you can write it as f of pi over 4 equals 2, right? And f of 5 pi over 4 equals 2. Sorry, it was negative 2. It was negative 2, and I just started writing 2. So that's not right. But if it was 2, it would be that. So if it was negative 2, let's practice again. I apologize. So at negative 2, same thing, let's practice again. It's going to be 3 pi over 4 and 7 pi over 4. And then if we wanted to write them as an equation, I guess, as a to solve it, it would be f of 3 pi over 4 is negative 2. So that's still true, it just doesn't answer the question they asked. And then f of 7 pi over 4 equals negative 2. And this is good to write out just to get used to, this is my x, this is my y, this is my x, this is my y. If they want it in this funky new notation, just put your x here, put your y after the equal sign. Put your x next to the letter in parentheses, put your y after the equal sign. Okay, so that's f, I apologize. And then G says, for what, this is a hard one, for what values of x is f of x greater than 0? What, okay, if this is 0, that means that's my output, right? F of x equals, I say y, f of input equals output. Another way to visualize it, okay? So what values of x is f of x greater than an output of 0 or a y of 0? Y is 0 x is, right? What points have outputs greater than 0? Outputs are y values. Which one would have y values greater than 0? So we're saying y is 0, but we're really saying y is greater than 0. Where is y greater than 0? F of x is greater than 0 anywhere it's above y equals 0. So that's f of x is greater than 0, and all of that is f of x is greater than 0. Okay? I can't list them because those are infinitely many points. I can only describe them as intervals, right? Every point on this interval has a y value greater than 0. Where is y greater than 0? Good? So between x equals 0 and x equals pi over 2, they have a y value greater than 0. Okay? Between, maybe I'll fold my paper. So where is f of x greater than 0? Where is my y greater than 0? It's between 0 and pi over 2. Also begins again, so none of those, begins again at pi, ends at 3 pi over 2. These are only x values. That's an x value, that's an x value, because this is interval. This is interval notation. So here are my x values for the times when y is greater than 0. Y is greater than 0 between x equals 0 and between x equals 0 and x equals pi over 2. Again, it is above y equals 0 between x equals pi and x equals 3 pi over 2. Okay? Those are all x values because that is an interval. Why up here for interval notation did I use the brackets and here I'm using parentheses? Pause it, see if you can come up with an answer. These are not intervals, these are points. This is an interval notation. This is an interval notation, this is an interval notation. These are an interval notation because it includes -2. Okay, but above 0, down here, it does not include 0 because 0 is actually equal to 0. Pi over 2 is equal to 0. Pi is 0, and 3 pi over 2 is equal to 0, right? We want it where y is above 0. So we have to exclude the points 0, pi over 2, pi, and 3 pi over 2. We exclude those points, but we go from there to the next one. From there to the next one. Okay? All right, for our final example, instead of looking at a graph, they gave us the equation in function notation. If it's already in function notation, that means it passes the vertical line test. If we graph it, we know it is a function, okay? So the function f of x equals f of x equals x plus 3 over x plus 4 could easily have been y equals x plus 3 over x plus 4. So if you are in Desmos or in your graphing calculator where you get to put in, where you can put in an equal sign, you can say y equals x plus 3 over x plus 4, or you can put in f of x equals x plus 3 over x plus 4. Good? So, they are asking us, once we have x plus 3 over x plus 4, to find the domain of f, right? There are two rules when you're trying to find the domain. The domain just means all the x values, right? When we looked at the big graph, no equation, we just said the domain is from x equals 0 to x equals 2 pi, right? That was our domain. Here, we have to exclude from the domain anytime there is a negative number under the radical or a 0 in the denominator of the fraction, right? Those are two things we can't do in math on the coordinate plane. We can't divide by 0 and we can't put a negative under the radical. So this has no radicals, but it does have a fraction, and it does have an x value in the denominator. If the x value is only in the numerator, we don't care because no x value will change the denominator. Because there's x in the denominator, that means the x value can change the denominator and possibly cause the denominator to be 0, right? If there was a square root symbol or a fourth root symbol, we would have to ensure that no x value would leave us with a negative under the radical. But that's not the problem. Today, in this problem, the only problem is that we have an x in the denominator, right? So in fraction form, maybe just looking at it, you can tell what value of x would make the denominator equal to 0, right? If it's not immediately obvious, you just take your entire denominator, ignore the numerator, take your entire denominator, set it equal to 0. X plus 4 is 0. And then whatever answer you get when you solve for x, it might be one answer, it might be two answers. Whatever answer you get, exclude that from your domain and you have found the domain. If you don't have this problem, if you don't have this potential problem and you don't have this potential problem, we just say the domain is all real numbers, okay? But because we have this, we're going to say domain is all real numbers except x when x equals, right? -4. X cannot equal -4. I think the way they want you to write it is the domain is equal to x such that x cannot be -4. So that is the domain of this entire function. X cannot be -4, okay? The next question is the point x equals 1, y equals 3/4 on the graph of x, okay? If it is, I should be able to substitute it into the function and it creates a true statement. So we've done substitution before, or we've done checking point if a point is on the graph before. One way to do it is to put the graph into Desmos and put the point into Desmos, see if the point is on the line of the graph, okay? Or if you have the equation of the graph, so for B, the point is 1, 3, 4. So the way I would write that for f of x is I'll just write f of x. F of x equals x plus 3 over x plus 4, right? So my x is 1, my y is 3/4, just because that's what I know about coordinate points, right? So when I put in a 1 for both of my x's, will f of x so we write that as either xy or x f of x, right? So all of f of x is my y, so it should be 3/4. 3/4 equals, and then I'm going to substitute 1 in for x, 1 plus 3, 1 in for x here, 1 plus 4. Is that true or is that false? 1 plus 3 is 4 and 1 plus 4 is 5. 4/5 is not equal to 3/4, so we say that this is not true. Is the point on the graph of f of x? No. Why not? Because 1 plus 3 is 4. 1 plus 4 is 5. 4/5 does not equal 3/4. There's no way to reduce 4/5 into 3/4. Also, let's look at Desmos. So I graphed our graph in Desmos, and then we're going to graph the point 1, 3/4. Make sure you zoom in. Once you zoom in far enough, you'll see it is not. It is close, but it is not on the graph. Good? All right. C asks, if f of x equals 4, what is x? And what point is that on the graph of x? So when we look at f of x equals 4, is 4 an input or is 4 an output? So just the -4. Is the -4 the input or the output? Remember, f of x, x is our input, equals y, or our output. So if it is not on the f side of the equal sign, it is our output. If it is in the parentheses next to the f, or it could be a g, that is our input, our x value. So if our output is 4, what is our input? If y equals 4, what is x? So C is, what is x when y equals 4? Yeah? And then what point is that on the graph of f of x? The point is going to be x, y, or x, f of x. That's what they want. They just want you to put it in coordinate point form. Okay? So f of x equals 4. That means I have that same equation, f of x equals x plus 3 over x plus 4. But instead of f of x, I'm going to put in 4. 4 equals x plus 3 over x plus 4. Right? And then I solve for x. How do I do that? Don't worry. You have a fraction. We don't like fractions. Let's get rid of the fraction. Don't even worry about the x. Let's just get worried about the fraction because we have an x here and an x here. So it's not going to be super simple to solve, but we can do it. Get rid of the denominator by multiplying by that denominator. So let's multiply both sides by x plus 4 because anything I do to that side to get rid of the fraction, I have to do to the other side. Let's distribute that 4. 4 times x plus 4 is 4x plus 16. This cancels this, and we just get x plus 3. Good. Now, let's just move the x's to one side and the constants to the other side. Subtract x. 3x plus 16 equals 3. Subtract that 16. And we get 3x equals negative 13. One more step. Divide by 3. Final answer is x is negative 13 thirds. Okay, so when y is 4, x is negative 13 over 3. So it's very similar to when we just put y equals 0, solve for x. X equals 0, solve for y. So our point is negative 13 thirds 4, because that is our x and that is our y value, or that is our x and that is our f of x value. xy or xf of x. You can check it on Desmos. So that wasn't on the point of the graph. Let's put negative 13 thirds 4 and label it. It is on the graph. You can also, once you know that y is 4, well, it's harder to do. Okay, so we found that that is on the graph. That point is on the graph. So we would write the answer as x equals negative 13 thirds. And then the point is negative 13 thirds as our x, 4 as our y. Okay? Last question is, what are the coordinates of the x-intercepts of the graph of x? The x-intercepts, just like here, we found the intercept with the line y equals 4, right? Where does it intersect with the line of y equals 4? Here we want to know the x-intercepts of the graph. The x-intercepts happen when y equals 0. The line y equals 4 intercepts with 4. The line y equals 0 intercepts with the line x comma 0. Or intercepts with the graph at the line x comma 0. So just like we put in a 4, now we're going to put in a 0 and solve for x. Okay? So our graph was y equals x plus 3 over x plus 4, or f of x equals x plus 3 over x plus 4. The x-intercept means we replace y with 0. 0 equals x plus 3 over x plus 4. Same thing. Let's multiply by x plus 4. On this side, let's multiply times x plus 0. Or sorry, x plus 4 on this side. 0 distributed by x plus 4. is just 0. 0 times x is 0. 0 times 4 is 0. On this side, we're getting rid of the denominator, and we just have 0 equals x plus 3. Subtract 3. Subtract 3, and we get x is negative 3. Good. X is negative 3 when, remember, y is 0. So that point is negative 3, 0, and there's only one of them, okay? What are the coordinates of the x-intercepts of the graph of f? This is a coordinate because it has your x, comma, y. So that's the coordinate. Let's check it in Desmos as the last thing we do. So now we're going to find the point negative 3, 0. And it's right there. You can also, so when x is negative 3, you can type it in right here, y becomes 0. And that is the end of this lecture. Thank you, guys.